Hello everybody, the Lord Root here, and welcome back to another KSP tutorial. I had thought about doing ISRU, but I didn't want to really spend a bunch of time getting a space station into orbit, and I'm working on a tool that will let me copy the space station we put up. But in the meantime, I thought, planes are something that we really don't know all that much about, and they can be difficult to get into. So maybe the first question is, what makes a plane anyhow? And that's a very good question. As far as KSP is concerned, we could take something like that, and it's considered a plane. The only real difference, in fact, there's no difference internally as far as I can tell. It's just where you launch it. And for most people, throwing a Mercury capsule with a fuel tank on it and a rocket is not really their idea of an airplane. It is a rocket that moves vertically, although there are, in fact, rocket planes. The Bell X-1 is an example of it. But generally we think of these horizontal-facing, these forward-facing cockpits here, and we have a couple. We have the Mark I cockpit, and its brother, the inline cockpit, and then we also have this guy right here, the Mark II, which also has a version with a nose on it, and then we have this guy if we want to get totally ridiculous for space shuttles. Space shuttles, of course, are an entirely different video, and they are very difficult to design. But a few things about planes. Planes generally have these jet engines, and jet engines are nice because let's just take a look at the thrust-to-weight ratio on this. And not just the thrust-to-weight ratio, but the ISP. The thrust-to-weight ratio isn't too bad, of course, but that ISP there, that ISP is 19.2 seconds, or kiloseconds, I guess. That has some implications. That means we take the smallest fuel tank we can imagine, and we put the very basic jet engine on it. We get about, 13 kilometers of delta V. But not only that, these guys only take jet fuel, liquid fuel. So if we take that out, we'll have a fully functional plane, and we will be able to fly that around like that. Now it gives us an extra kilometer and a quarter of delta V. Now let's just move this guy up. Let's assume for a moment that this guy is ready to fly. Well, is it? I mean, we're not going to die if we take off the launch pad. Even though I have Bill in here, it seems that this guy might come with stability assist in it, so that's good. Let's hit spacebar. Uh-oh. What's the problem here? We have no intake air. So the reason that these guys don't require oxidizer is that they pick it up from the surrounding air. Now, that actually has some implications for it. The first of which is that if you played Spaceplanes in any of the earlier versions of KSP, and I think they came around in 0.18 when I started playing, they were, when 0.18 came out, I didn't play that much. I didn't play that much until the tail end of 0.19. But, you used to be able to just throw on a bunch of air intakes, and these air intakes are, that's when, this one here, looks a little bit like a horn, like a bullhorn here. This one too. Let me put that on now. we will be able to take off. Albeit with a lot of drag. That's kind of the disadvantage of using these air intakes, is that they not only have drag because they stick out, but also they have intrinsic drag as well. What is going on here? Okay, let's just turn on the engines anyway. Yeah, now they are coming on. And, I'm moving about. This isn't a very effective plane, of course. It's, really got no way of getting up. And we will probably shortly crash. By the way, these guys do have reaction wheels in them, although I do not believe they are terribly strong. That could help if you were missing on control. Let's take another design, though. Let's take this inline cockpit. Let me build one with the circular intake. And maybe because this looks kind of like a Vietnam War airplane, in a way, what I'm going to do is I'm going to put the fuel on the back. And I'm going to take that engine there. Obviously, we need wheels, right? And that is going to be an issue. Let's put some wings on this thing as well. There are lots of wings to choose from. We have this big guy in it that has fuel. That, could be kind of fun. Then it becomes kind of like, I guess like a flying wing. Though, yeah, we still got plenty of thrust-to-weight ratio here. And I just want to check something here. That is not quite what I had in mind. Let me just move this guy forward just a little bit. Maybe like that. We also want wheels, of course. Wheels you'll find under the utility tab here. So we've got, we can create a little tail dragger design here. If we can just get the wheels to point the right way. And I'll put them over here like that. And put the tail in the back, or the other wheel in the back here. In fact, I'll do something kind of like this, maybe. I never really liked these wheels. But let's try flying it and see what happens. Because it may surprise you. I mean, we got these huge wings. Certainly it will get into the air, right? But we'll have to see. There is a ton of lift here. We'll pull back just a little bit. We are beginning to turn off the runway with no real way to correct it. Well, I suppose Bob at least is doing okay. We don't have any air. But, you know, those big wings aren't helping us any. So, to help prevent the turning, one thing we can do is we can put on a tailplane. Is that going to be enough? Let's take a look at this again. We have our wings way up in front like that. We are more or less able, you know, to hopefully control this thing. We'll give it another shot. It's probably for some of y'all, apparently obvious that we have a little bit of control over our plane, but not much. And of course that happens. We were a little bit more stable though, so what we could do is we could throw on control surfaces. Now this guy up here, this tail fin, it's a winglet and it is a control surface. But this guy back here, not so much. It has no way of adjusting itself. So what we can do is we can maybe grab one of these and throw it on the back like this. And of course you hit X and we will get that going on as well. And with some amount of luck, we will be able to keep this thing. We'll be able to get it into the air before it gets into anything else. So we'll just pull back here. Maybe try to get some control over it. And we're able to get into the air, but we've lost control almost immediately. Why is that? Well, the reason for it is largely because of one of the number one rules of thumb that I think everybody should be aware of. It's something that is not trivial. Of course, this guy is a little bit heavy, these wings, but in addition to that, let's just take a look at what happens when we have our wings up front like that. This guy is a lever, and what's going to happen is that as you move through the air, you've got lift on the front of the craft, and that generates lift on this cockpit and pushes it up. So far so good, but that is, you know, the problem is once you pitch up, this guy will continue pushing back. So this thing is intrinsically unstable. What we have to do in order to rectify that is we need to find maybe not only a wing that is so, I suppose, out there like that, that's so difficult to use, but we need to put this guy slightly behind the center of mass, because this guy's a lever. And so with that lever, what's going to happen is this guy right now is going to have the tendency to be pushed down, but if you throw this guy back here like that, then it won't put too much pressure on it, just won't too much force here. It just it'll have a little bit more trouble rotating. Let's see if maybe after doing this, after maybe throwing on a couple of control surfaces, and there are many, for instance, you know, for instance, we have this guy here. This is a little bit big, so I'm not going to throw it on, but let's maybe put on one of these guys here. In fact, these swept wings are a little bit dodgy, so I'm going to take them off, and I'm going to put on just some straight wings, if I can find them. There are lots of wing pieces here. This wing connector B, I think, is a good place to start. It's nice and it's flat. And by the way, these control surfaces have lift as well, so that's something you'll want to take into account. But we'll throw this guy back here, like so. we will put on some control surfaces. Now, you'll notice I have two pairs here. I have one that is in the middle and one that's on the outside. You can right click on these guys, and for instance, we know that this guy only wants to do yaw, so we'll set yaw only, and I'm just going to call this plane 1 so we can revert back to it. Let me explain the degrees of freedom on this real quick. Your up and down direction, like so, is called your pitch, and your left and right is called your yaw, and then if you rotate, that's your roll as well. So that's good to know. I'm gonna just reload this, but yeah, we'll bring up if I can find this, the plane 1. Such an inspired name. If we load this, what we can do then is pitch. We probably want as much help as we can get. We do not want yaw control there. Here we want the opposite. If the button is depressed here, then it's disabled. And here, because it's in the center, we want to turn off roll as well. Now, of course, we need wheels, and there's a bunch of them. I'm going to go with this nose gear here, and that should allow us to move forward just a little bit. Now, you may be tempted to do something kind of like this, where you want to make these wheels level, and that, as it turns out, can be a bad idea if you're not really thinking about what you're doing. And the reason for that is because, I mean, we should be fairly good in terms of our pitch or whatever. We're not going to flip out, but try as I might, and I'm just going to be holding back the entire time. Now, this guy can get pretty fast. It has a little bit of a limit to it because the wheels in this case are not retractable. In this case, I had enough thrust to take off, possibly because of the center of mass here. Generally, however, you won't have that if we instead... Let me just make sure that everything is set up here. You know, sometimes I'm just going to take this off. I'm going to put smaller wings on it. We'll use our same rule that we had before, like so, because this will work. I'm fairly certain of it. Let's say we have something like this. Really stubby wings that don't really get us much in the way of lift, but maybe enough for this. Now if we try the same thing, and we try to move forward, we may find it very, very difficult to get off the runway. You can see we're going quite fast now. We don't really have this excessive lift, although we probably do have enough to fly the plane however we want to. And it almost seems as though we'll go off the runway like this. Like we'll just crash into the ocean. And what will happen here, of course, is that we'll be able to take off, but we couldn't turn around. Well, let's just revert back to the Spaceplane hangar and see what might have gone wrong. In this case in particular, we have our, whenever we're pulling up, this guy's pushing down on the wheels, and so all of that downward force is being lost. They're being absorbed through the wheels. If we moved these wheels forward just a little bit, maybe like that, into this, where the center of mass is, we will get a pivot going on. And let's just wait for that to load there. You want to be careful with this, of course. This guy has a tendency to fall over like that. Something we should be able to fix if we pitch the nose down just a little bit. That condition, by the way, is something called tail striking. And it's not a good thing to happen. Now it's a lot easier for us to take off. So the main question is, okay, well, with we'll just go back to a regular plane design. That, you know, that's a bit of a problem. How do we get around that? And the answer, of course, is that we can move this guy back up here. We can move it up to where it would normally be and give it a bit of a pitch. And that way, when we take off, we will, in fact, I'm not going to touch the controls at all here. You will be able to sort of see what happens. We've already got, like, this built-in angle of attack to where we're biting into the air. And what will happen here is we will sort of start moving forward just a little bit. And really one of two things will happen. We're taking off almost immediately. I have not touched the controls at all. So this is a good thing. We can fly around like so. I just want to show you, like, turning with your rudder makes flying the plane very, very difficult. It's, in fact, possible for you to stall out like that. So, an easier way to fly around like this is, you can rotate with Q and E, your roll controls. Now you can see the G-forces are a little bit high here. I'm just going to fly around here for a little bit. And we can maybe attempt a landing. There's another maneuver as well that you can do if you want to fly around, where we could maybe, let's say we want to turn 180 degrees. We can go like that. And we can roll. And that turned us around pretty well. Anyway, this guy is moderately stable. We could cut the engines, in fact, and it would probably glide. And one thing about these jet engines that you should probably be aware of, by the way, is that they have a spool down time, you can see that it is taking a little bit of time for our thrust to go down to 0. Anyway, I'm pretty close to the KSC, so I'm going to maybe attempt a glided landing. We're losing energy, by the way, by doing this. It's not generally a good idea to... Something like this could probably fairly easily glide. But for most other aircraft, you have this issue to where they will begin to fall rapidly. To incidentally, we can also hit C, and if we would like, let me just turn off engineer real quick. We can just sort of fly around as we wish. And of course, there is a radar altimeter which tells you where the ground is. It says we're probably about 2,000 feet above the ground or so. And there's, you know, here we're actually doing pretty well. We're gliding. Anyway, we can sort of expedite the process if we want to. I'm just going to give the engine a little bit of power because I am not very good at landing. We can do a couple of roll maneuvers to get ourselves lined up. Probably can even stand to drop a little bit. You can see we're not dropping too terribly fast yet. Still not lined up with the runway though, and that's a bit of a problem. And lining this thing up can be a little bit difficult. I was impatient and so could not be bothered to wait. I am just going to begin rolling back over here now. And when you pitch up, you'll notice you slow down. We're coming in fairly you know, we've got a bunch of lift here. Might be good for us to just move this guy over just a little bit. And I think we're right over where we need to be. This is, of course, a very difficult thing to do if you have no idea where you're supposed to go. But we'll flare up here. We don't want to get too much in the way of lift. And we'll use the rudder to control our landing a little bit. And B for brakes. We bounced a little bit, but we might even... You see, we got so much lift that our back wheels aren't really touching the ground. So, you know, that's a disadvantage to it. We'll just go full stop on the brakes. You can hold these down here. We are going off the runway, it looks like. So, there's a number of things we can do about that. The first thing you might want to do, of course, and I am just going to save this as it is, but I'm going to create a new part here, a new pod. I'm going to get somebody here to step out, and we can pretty much, knowing where the edge of the runway is, it's possible that we can place a flag. So we got to remain somewhere in between these lines. We'll just get Bob to go out on EVA mode here. Yeah, we'll say KSC landing strip, and we'll recover him. That means, of course, that we can get Bob, able to do his thing there. We'll just leave that there for now. We'll go back to the plane, and we will see another thing that happens here. If we just go to plane 1, because I am completely uninspired. Now, we have plenty of fuel with this. One thing, of course, that is worth mentioning is what happens when your fuel burns. Sometimes, probably because we have this air intake, you'll be lucky and it'll move forward and it won't cause much control loss. You take this guy off, and unfortunately, what could happen instead, because of the positioning of this engine, is with enough mass, your center of mass will actually move backwards and cause you to lose control. I don't really have an example of such a plane readily available, but you'll notice too there are minor stability issues with this. So one thing you can do is you can give this thing a slight dihedral angle. Now, if you hold down shift, you can very finely control that. Our landing gear is going to stay about where it needs to be, and this thing will eventually correct itself. Because what's going to happen is, let's just say for a moment, and I'm going to call this plane 2. Let's say that we happen to have this guy, and we're tilted over like so. Well, what's going to happen is that the lift from this wing is going to push this wing up and correct it. Likewise with this. So how high can you get with such a plane anyway? Well, you can get pretty high. You can, in fact, maybe get up to 15 kilometers before the engine cuts out. That's something for people who have played KSP before, that are used to the old ways. The way back before 1.0 is that you could throw a bunch of air intakes on, and you can get ridiculously high, and the only real difference was that your engine ISP would go down. Let's try that because we have the thrust to weight ratio. Let's just go completely up. This is not usually a good idea by any stretch of the imagination, but you could do it. We're very likely to roll around at this point, and what will end up happening is we'll bring up our resources here. We have plenty of intake air, and it won't take long for us to get up out of the atmosphere. But let's watch this guy right here. We are already beginning, as we move through the atmosphere, to lose thrust. And that's a bit of a problem. At some point we'll get high enough up to where, despite our vertical speed that is slowly dropping off, and we'll just level out here just a little bit, you can see our intake air is still good around this point. I'm going to try to keep the vertical speed maybe constant so we don't run out of intake air in the interim. But what will happen is that we'll get up to some 1,500 or 15,000 meters, and you can see we are losing thrust quite rapidly already. Our time to apoapsis is going down. We need to pull up just a little bit if we can. But the thing is when your intake air hits 0, then it becomes a bit of a problem. We'll just increase that. You can see our thrust is minuscule. In comparison here. And we were in fact not able to get up there because of the approach I took. So I'm going to revert the flight and show you what happens when I do get up there, because this approach will take a little bit longer. Okay, so we're getting pretty close. Just another couple 100 meters per second to go. You can see our fuel is perhaps, or our thrust is going down quite a great deal. But we still got 9.1 kilonewtons of thrust. And that's a good thing, right? If we could, but get that 100 meters of, or so of, distance covered, then we'd be good. And it would appear as though we could continue to fly like this indefinitely. What will end up happening eventually is that our engines will cut out, and there's nothing we can really do about that. And that's rather unfortunate because the engines are providing much of our electric charge. But yeah, so we need beefier engines. We need engines that are designed to get up into higher altitudes. Now, there's two alternatives for jet engines. One of them is this guy right here, the Whiplash, the turbo ramjet, and we get about half the delta V out of it, but that's still a lot of delta V, a ton of thrust, in fact probably so much thrust that if we were to take off like this, that we would be in a very bad scenario. And the ISP, the thrust does go up with the I suppose with the altitude as well, but there becomes a certain point as well where that's impractical. Let's just take off here. Let's get as high as we can. I'm going to, and this thing will get you going really, really fast if you're not careful because of its thrust. You can see we're already past Mach 1. We will soon be going past Mach 2. And, you know, we're doing it on the whole intake air situation. And we were beginning to catch on fire, which could be a bit of a problem. These plane parts, by the way, can handle up to 2,000 degrees or so, but we're now at the point to where the primary issue, so that was about 25k or so where that engine cut out. Oh no, we flamed out. Incidentally, it's possible, as long as you're pointing prograde, if you actually do have the air, you can get up here. You can see, though, we are actually going out into space with this, thanks to the fact that the atmosphere is thinner. So, we could slap rockets on this thing, in fact, and we would get into space very easily, in fact. But, oh, there we go, we're on a time warp. This really gives rise to the next engine, which is a special kind of engine called the Rapier. And so with the Rapier, what you can do is you can stick this guy on the back here. Let's just take a look at our center of mass. It's a lot heavier than most of the rockets, and I'm still surprised we can go forward with the fuel. But if we made a really stupid decision, like let's say we have this guy here reserved for whatever point, and this guy starts to get real heavy, then you can see we're moving less and less. This actually maybe isn't such a bad design when you really think about it. Might be difficult to land, but the center of mass is more or less constant. Only trouble is, at least in the old versions, I think they may have fixed this in the new version, but let's try that very same thing again. So we have a very large amount of thrust here. This guy has two modes. This is air breathing and non-air breathing. Now, you'll notice, oh, way too much thrust to weight ratio. Let me try that again. Yeah, incidentally, in the new atmosphere, you have to be very careful because of the drag. What happened there is that we moved so quickly that we had moved way faster than our thrust to weight ratio can deal with. Or not our thrust to weight ratio, our prograde vector. We're just interested really in getting this thing into space. Maybe the center of lift may be a little bit ahead of this guy too. It's a little bit tail heavy. But we'll get us some lift going here. We will be going a lot faster than maybe we should be. Fine control for something like this is actually a really good idea. And here there is a nominal angle of attack. I'm going to assume it's about 30. There's no good reason to make that assumption, of course. But yeah, this guy can get plenty fast. While we're in the atmosphere, we do not want to go much above Mach 1 or Mach 2. If we're not careful, in fact, we can go very, very fast in the atmosphere. So we're now almost Mach 3. Might be time to throttle back just a little bit, as this guy is going to start overheating pretty soon. Fortunate. Oh, yeah, that we're going way, way too fast. We're going to start losing parts here. In which case, it's actually probably okay, despite the fact that we lost our horizontal stabilizer. It's okay for us to maybe, there we go. It's kicked into, it's automatically kicked into closed cycle mode now, and it's now possible, as long as, you know, we are careful about, it's possible that we will be able to get into orbit. In fact, I know it is, and we're gaining a little bit of altitude because of our wings, which is a nice touch. At any rate, we're in space now, and we can circularize this if we want. We're very inclined. It won't help us get to the space station, but it is possible. Just, of course, we don't have enough energy because we went straight up like that. But yeah, those are the engines. I suppose this is a good place to stop it for now, because really, there's more advanced topics would take a lot longer to cover, I suppose. But I do intend to cover them eventually. For now, I think it's good that you just sort of have an idea of what's possible with planes and how we could really deal with those issues. So, of course, things to remember. We want to make sure that we do not abuse our temperature limits here. And that means not going obscenely fast in the atmosphere. That's a problem. Remember that these engines here, that they have limits. And generally, like with rockets, you don't want to go too big with these. Anyway, this has been Thy Lord Root, and I will see you next time.